HTML and CSS. Okay, but ultimately, I want these two classes to be about computer programming. And if you take computer programming out of context, if you don't put it in context, it's actually quite dull. So I needed to put it in context. The context I chose was HTML elements and objects, and showing how you can manipulate their properties and attributes dynamically on the client side. So really, this is a discussion about. So today's class really is going to be about a little bit about information technology and about HTML and CSS. And then Thursday's class is really going to get more into how you manage these things programmatically. So then Thursday's class will get into computer science and that sort of thing. I'm hoping that you guys attend. I feel like I had to almost bait and switch people to be able to come to this lecture, since, I don't know, like I said, computer programming can be, I find it incredibly exciting. It may not be everyone's taste. Okay. When I attend lectures like this, I always, whether you learn something or not, it remains to be determined. Something I always get a benefit out of is introducing myself to my peers around me. And to facilitate that and to further just help with retention of the material I'm teaching, I'd like to pair all of you up, starting maybe from this side of the room, and just you can pair each other up, because there will be quizzes every 15 to 20 minutes, and you're actually going to quiz each other. So maybe you guys know each other, but anyway, just find a partner. The next 60 seconds.
I guess I can't read the other things I've seen here. At least we have at least we have someone on the end though. Yes. But yours is fine. Or I just can't see it. It's made it. I have no idea. So, I go to the workshop. You'll do better on the computer. Thank you.
That's exactly 60 seconds, but let's get started. I am concerned that I don't have enough time to get through all the slides that I've prepared. So I'm going to go a little bit quick. Again, quiz time will give you a chance to give me a chance to catch my breath, and give you a chance to collect your thoughts. And really, what would be helpful, this is the first time I'm presenting this lecture. If you guys note any slide that you find confusing, there's a slide number at the bottom. Just write it down. This is the feedback that really helped me. So, I can take anything. So you don't worry about insulting me if you have feedback. I just need sincerity. That's all. All right. So the first thing is why. Why learn computer science, and more importantly, the computers and the algorithms that drive computers. And I realize that I'm kind of preaching to the choir, but whether you realize it or not, computers are a big part of our lives, right? I mean, you might think of a traffic light as something that has, a couple of egg timers in it and some electromechanical switches, but the reality is there's lots of lines of code that operate that, And they now they're part of our food chain. A friend of mine that used to come to Gangplank, he now works over at John Deere on their autonomous farming vehicle project. Okay, so. And late at night when your own mother won't warm your food, the computer will go ahead and warm your burritos, and thank you for the privilege, right? So the point I'm trying to make, this slide has a point, okay? And the point is I'm trying to make a distinction between what's known as embedded programming and general purpose programming, okay? So when people think programming, they think I'm going to program for a desktop computer and for a laptop, okay? But you have to remember there's millions of lines of code written every year that do specific things and do them incredibly well and reliably. And the program never changes. And when you go ahead and put a CPU in any device and have this code that just is static, that's known as embedded programming. And there's a club that meets here second Wednesday of every month at 7 p.m. It's called the Arduino Club. That's a great introduction to embedded programming. And I find that's really where my passion lies. I really like getting a computer to actually control things and assist with our lives. Enough with that. I do want to continue focusing on why, and that's because this class really is about it's really about what, why, and when. Okay, what's out there? What tools are out there? What can you use? And when to use it and why you use it. Okay. You can see at the end I have how written in small text. That's because once you know the what, when, and why, you can kind of figure out how. Right? You can go ahead and Google search these, or you can ask one of the experts in the room. Okay, but I find a lot of times when people learn a new skill, they find it so frustrating because you go through this period of temporary incompetence, right? And it's very uncomfortable. And really, what I'm trying to go and focus on the fundamentals the definitions, so at least you can frame your questions in an intelligent way. Maybe the learning curve isn't so painful and you go on to actually enjoy this, and whether it's for profit or for pleasure. All right, so first distinction is the server-client distinction in the context of website or web programming, okay? This lecture is really going to focus on, when we do examples of programming, it's going to focus on the client side, okay? So really what the client is in terms of web context is the client is the computer on the desktop that has the web browser running that makes the HTTP request for HTML data. Okay, that's the client. The server is the computer somewhere out in the cloud, what we used to call the internet, now we call it the cloud, okay, that goes and responds to that HTML request, okay, and that's done through the HTTP protocol, all right? So this is actually from Linux Journal, this slide, so I can't take credit for it, but I took the analogy a little further, okay, sometimes people say front end when they're talking about client side, and sometimes they say back end when they're talking about the server. So just remember that the calf's crown is in the front and the mother's udder's in the rear, or the back, sorry, and you'll never get those two confused, okay? So let's take a look at how an HTTP request gets filled. And again, I don't know anything about your background. It's very hard to prepare a lecture when there's a diverse background in the audience. So at times it seems remedial. It's not to frustrate you, but I hope you get something out of this. So let's say I have a computer here at Gangplank, and I go ahead and make an HTTP request to Google, all right? The question is, in the end, the reality is Google, like many other institutions, use a content delivery network. Computers are spread all over the country, okay? Some are leased. Google didn't build their own server farm until 2006, so clearly many years they went leasing it. But nevertheless, in this example, we're going to say that in the end, you're going to connect to a computer in Mountain View, California. This is a bit of a fancy here, but anyway, it's good for illustration. So how do we get there, right? So the first thing the computer does, it actually checks itself. It checks what's called a host file. Every computer has a host file, okay? And really, you have to understand the HTTP protocol sits on top of the IP protocol. And the IP protocol doesn't understand domain name any more than if you pick up the phone and shout, Bank of America. The phone does not understand what that is, right? And you might have a smartphone that does a translation of your voice to an actual sequence of numbers. And that's what we need to do, right? We need to go ahead and translate google.com to a unique IP address in the world that it represents the actual server that will reply to this HTTP request, okay? So the first thing you do is it checks the host file that exists on the computer. Okay, I'm going to show you my host file really quick. And let's see here. Camera window I wanted to use. Maybe this one. All right, so on a Macintosh, it exists in the etc directory. First of all, is this font size okay? Can everyone see this? Okay, great. So ignore anything with the hash mark. That's a comment. It's not important, okay? And I'll spend a few minutes on this, but this is the problem with any topic that's technical. There's so many tangents you can go on, so I'll try and stay focused. It's not my strength staying focused, okay? So the first thing you can see is an entry that translates a domain name called localhost to this domain name, 127.0.0.1, okay? That is a reserved number that everyone in the world understands. When you use that number, it's referring to your own computer. Okay, so, and I'll show you why that's helpful later. But anyway, so just remember that this is a reserved number. When you see that, it really means your own computer. Okay, why would you want to do a request to your own computer? I'll show you later, okay? Ignore this one. You can go ahead and take a look at the next line. You can see that I've translated my own personal file. I've translated bankofamerica.com's website into an IP address, okay? And the reason I do this is that, let's suppose you get your Yellow Pages delivered to your home, okay, and you look this up to go ahead and call Bank of America. There is a possibility that the printer has some slimy relative that's went ahead and erased Bank of America's actual number and typed in his own home phone number. So when you call Bank of America and get their information, you're giving somebody else the information, okay? And so that's the problem. If the information doesn't live in your Etsy host file, it has to get it from a third party. And sometimes the third party DNS, we'll get to that later, can be corrupted, okay, through hackers or whatever. So I sometimes like to wear a belt and suspenders. This is a demonstration of doing that. I have that in my Etsy host file, okay? And then I could go on and on, but like, I was addicted to Sudoku for a while, so now as soon as I go there, it goes back to my own computer, I get a blank screen, okay? I am gonna mention a few of these other guys just because it's helpful to understand the way a web page gets built, So let's say I go to my favorite blogger's webpage. All right, so it gets loaded onto my computer, but he can embed JavaScript code that calls in a plugin to, let's say, advertisers. Okay, so it gets rendered on my page, and then once it gets rendered, now it's going to be filling in a column with advertisements. Okay, and there's certain advertisers I feel cross the line. They break my pop-up control, and they do other things. So this is kind of my on-notice list of advertisers for that. So anyway, you get enough of this demonstration. I'm going to move on. Okay. Fun presentation. All right, so we covered. Let's keep it here. That's my mic. Okay. Right, so if you looked at my Etsy host file, yes, sir.
You put your local host for the websites, but it still renders the website in your.
No, oh, see, this is something that maybe that wasn't clear. Okay, so when you go to your blogger's website, it wasn't an Etsy host. Okay, but that blogger's website included links that load code from these other websites, and it's when it tries to load those links that it gets shut down. It says, try and load this link. It's like, oh, wait a second, don't load it. Actually, look at your own computer, and it looks at my own computer and can't find the information. And that's the thing with HTML and to some extent JavaScript. It kind of fails gracefully. Okay, it realizes that it's not going to go ahead and run anybody over. It's not an autonomous farming vehicle. It's just a damn website. So if there's errors, it just kind of marches through most of the time. Okay, and that's why, or quick tangent, that's why we have so many different programming languages. Really, there's special circumstances that require, let's say, extra security, extra precision, extra fail-safe kind of concerns that make some programs very strict typed and others loose typed. JavaScript is known as a loose type language. We'll get into that in the next presentation. All right. Okay, so if you looked at my Etsy host file, there was a google.com, so the computer still doesn't know what to do. Okay, so the next thing it does, it goes to the back room here, there's a cable modem, and it asks the Cox cable modem, hey, do you know anything about this? Sorry, Jerry. Okay. You know anything about this IP address? And the Cox cable modem does not, but the cable modem is programmed with 2 IP numbers called the DNSs. Finally, my computer has an IP address that it can contact. Okay? So far I try to get to Google. The only IP addresses I get are ones built in kind of to my modem, the DNS numbers. Okay? And as I mentioned, the DNS is nothing but like a yellow pages for the internet. When it contacts Cox DNS, I get a translation of google.com to an IP number. So great, now with the IP number, I can go ahead and traverse the internet backbone. The internet backbone is a kind of a redundant set of routers and cabling fiber optic owned by the major telecoms. So, you know, MCI, AT&T, Quest, okay, and then they sublease some of that to your local ISP. It's a really confusing, that industry is extremely confusing how the business relationships work, but nevertheless, it works, okay, and you wind up going to the to Google's head-end router, okay, and of course the head-end router at Google is not some cable modem from Cox I ran out of graphics. It's a very sophisticated network appliance, right? Because that network appliance is going to figure out which one of the many servers are going to go ahead and respond with the HTTP request. Okay, so that's what's kind of called, it's called load balancing. All right. There's another distinction that I want to make on this slide, and that is you can see I have this WAN IP address for the Google head-end router. But when you look at the server, it said, great, I'm going to go ahead and forward it to this server with this IP address. Okay, so once you're on the non-internet side of the router, okay, you can have any IP address you want. When you're on the internet side of the router, you have to have a unique IP address in the world. Okay, so this is an address that's unique to Google. All right, and this is part of the problem you hear sometimes about IP version 6. Okay, we're running out of numbers. If you look at this, each one of these numbers go from 0 to 255, not 999. Because of that, there's only 4 billion combinations, and we're running out. Version 6 addresses that. Adds a lot more addresses. I forget the total number of bits. Okay, but one way we can address this is by having a separation of the network, so that I have my LAN side versus my WAN side. So let me demonstrate that just real quick here. I was going to do that. So if I go, for example, to whatismyip.com. You can see that if I go to a website, whatismyipaddress.com, it tells me this number. But if I go to my preferences on my Mac, okay, and look at my IP address. Find this. Okay. If I go to my preferences, you can see I get a different address reporting. Okay? And that is because that website that I did is in whatismyip.com can only see the router's IP address, the one here at Gangplank. So every computer here in Gangplank, if they go to whatismyip.com, they're going to see that that other 70.xx, this number. Okay, that is unique to Gangplank HQ, this building here. Okay, but once you get on the router side, you have I forget how I'm showing this. Preferences, right? You can see that I have a LAN IP address, not unique in the world, but unique inside here in Gangplank. Okay, so anyway, I think I've beat this topic again to death, which I will repeatedly do in this presentation. So let's move on. I'm hoping this is helpful to some people. Again, it's maybe not really useful information, but you kind of need to know what's going on. Yes? Oh, sorry. Okay, so here we have a situation now. We've made an HTTP request to a Google computer, okay? And that computer, just because it's a computer doesn't mean it can respond to HTTP, right? Any more than if I gave you a jump drive and said, hey, open this Adobe Illustrator file, your computer might or might not open. It depends if you have Illustrator installed, right? It's the same thing. The computer won't do anything unless it has what's called a server, or in this case, I'm just going to jump to the answer. Apache is a very popular program that you can install on a computer and that runs, that knows how to respond to HTTP requests. Okay, so if you go and buy hosting, let's say GoDaddy, you'll often see that, oh, it's Apache, this version. It's the most popular one out there. Okay. But the other thing is that it's not sufficient just to go ahead and give a HTML page. There's other things that are very popular to go ahead and do with the page, right? So PHP is a very common programming language people use on the server side to go ahead and dynamically change a website or web page, and I'll show you how that's done in a minute. Right? SQL is also, or some type of relational database program, is critical on a server, right? So I'm logging in to my Gmail account on a Google server. It needs to have this data stored somewhere, what my password username is and all my past emails, okay? And very common, that's the, SQL is a really popular database. It's so popular that, that they've actually gone ahead and stacked all these together in distributions known as WAMP, MAMP, and LAMP, okay? And the AMP part of it is for Apache, a open source version of SQL, and PHP, okay? The W, M, and L portion of it are for Windows, Macintosh, and Linux, okay? So I have a little Linux box at my house. It runs all my personal websites because I have a static IP to the router at my house, okay? And literally it's a $139 netbook computer, and it's able to serve, you know, one day it's 1,200 pages an hour. I mean, it's pretty little computational power is required at times, depending which web pages to. So the other reason you might do this is for testing your web pages, right? Because the reality is just pick GoDaddy. It's kind of a pain to manage your own web server, okay? But for testing purposes, like on this Mac, I went ahead and installed MAP, all right? And this way I can go ahead and completely test and stage a website before I make it live. And there's probably easier solutions, but anyway, this is a popular solution. It comes up often, you kind of need to know about it. All right? All right, so so what is the difference between HTML and PHP? And so you can see if I have an HTML file, this HTML file does nothing but says today is Tuesday. It is Tuesday. But the problem with this file is at midnight tonight, I will have to get up, go to my server, and change it to Wednesday. Okay, it's a very poorly crafted web page. Okay? So instead, you can go ahead and change it from index.html to index.php. And if you have a PHP interpreter running on your computer, which you do because you've installed WAMP or LAMP, okay, it's going to go through this file and look for this bracket PHP question mark tag. Okay? And when it does, it'll first go ahead and run and evaluate this expression and then dump that content to the page. Okay, so a very common function in PHP is the date function. The date function takes, I can't remember, maybe one parameter. In this case, I passed it lowercase l. Lowercase l is the parameter you pass that function to get the day of the week. All right? All right. So in that case, then today, it would just say today is whatever today is. Okay. Yes, sir.
The date is echoed based on your OS and your computer time set, right?
That's right. That's right. So then really, there's a concept called a timestamp. Okay, and timestamps are like the number of seconds since in some cases, like the unit epoch, since like January 1st, 1970, in Greenwich mean time. And this way, it removes the whole context of time zone. Okay, so there's ways. So sometimes you'll see something that's called a timestamp, and it's a number of seconds, and it's a lot of numbers of seconds. And that's just a way for you to deal with the fact that servers are in different time zones, and computers don't have to worry about that because it's dealing with an absolute numeric value. Anyway, hopefully that was meaningful. All right, so it is quiz time. You're going to find your quiz buddy, and whoever's on the left is going to answer this question, and then you just alternate the right guy answers that question, and so forth, and then I'll do a quick review of the answers. You have, let's say, 1 minute to do this quiz.
I just know the
I didn't catch which file was it. It's HTX, the host file.
I'll go.
Is it the host file?
I don't know. I don't even think it was down.
All right.
Okay. What is the name of the file on your computer that provides domain name to the IP section?
I think that's 60 seconds. I'm going to go through.
I don't know.
I'll pick out the answer. I think everyone, this is pretty easy. So Linux package server MySQL PHP. Here's the name of the file on your computer that provides the domain name to IP address translation. It's your host file, okay, your Mac, it's your Etsy directory. What's another name for client and server? Class? Front end and back end, yes. Okay. And what is MySQL used for? It's used for database storage on the server. Okay. Or data storage on the server. Wrong here.
People call those stacks.
Okay. So I'm hoping you guys are getting something out of this class. I don't know. Again, I don't know your background, but I maybe have gone.
The guy next to me is so much smarter than me. That's what I've learned so far.
All right. So yes, that is a rabbit hole. It's there for a reason. You're going to see over the next couple of slides why the rabbit hole is there. The question is, what is HTML? Okay. So HTML is an ASCII encoded markup language that describes a web page's layout and content. Okay. So it's not the first markup language. I have a real affection for markup languages. When I was in college, all these people had these Windows 95s, nice computers, and if they wanted to do some mathematics, they would go to the menu, pull down the integral symbol, pull down infinities, that sort of thing. And I had like a vintage Model T100 laptop that was from Tandy. It was about 10 years old. And I could go ahead, because I knew markup, do some really nice mathematical formulas. So instead of going and looking for an integral, I could just type in like \int. And then I would run that through a processor that would give me a PDF with a nice integral sign. Okay, so markup comes up, and that, anyway, maybe it's a total tangent, okay? But markup, the whole point is that you can use the most basic text editor and create a very rich visual page, okay? So you can do this with Dreamweaver, and there you get your GUI. But the reality is you can do a web page with a computer from 1980, literally, because once the ASCII standard came about, okay, and that's really the first question, what is ASCII? It created the standard, and that created the first, most popular computer program, and that is the text editor. And these text editors are compatible across all machines. Okay, if I have a 1980 computer and generate a .txt file, you can throw it in a nice new Mac and open a TXT file. Okay, so the question is what is ASCII? Okay? And so ASCII is a standard. It's an 8-bit encoding standard for alphanumerics and punctuation. Okay, so if you look, let me see here. All right, so I have a little ASCII table that I can pop up because I refer to quite often. Okay, there's 16 rows across, and so you can see that the 33rd character is a space, and the 34th character is an exclamation point, and on. You can see how so basically this is the only reason this matters because everyone in the world has agreed that this is the way things are. Okay, and that's a differentiation between when they call something a proprietary format versus a standard. Okay, it's a global standard. Everyone understands ASCII. Everyone agrees the 65th character is a capital A. Okay, and that's how this way I can transmit a binary string and actually render it back as some meaningful value here, or at least some symbol that's represented on the screen. And that's a point. The distinction between hang of this microphone in a second. Between symbols and the concepts they represent. This is, I think, a problem that humans have a hard time with, okay? Because we are just so accustomed to seeing a symbol and thinking that the symbol and the concept are intractably linked. I pronounced that word right, okay? But you have to remember that, we use the numbers 0 through 9. Other cultures use other different squiggles to represent those characters, right? So there's nothing inherently better about a particular symbol you use, okay? But this is a point I guess I'm going to make here. Here's a binary value that represents 1, okay? That binary value is, I believe, 49, okay? So here I'm saying 49 represents 1. Well, 49 represents the symbol 1, the way I'm going to draw these squiggles on the, yes, sir?
39.
32 plus 16 plus 1? 49.
0011 is 3, right?
Well, yeah, but sorry, not hexadecimal, decimal. I'm talking about the 49th character. Okay, so if you were to look at the sequence, and I'm really going to talk about when I talk numbers here on out, I'm talking with, you're going to think about the words I'm using for the number, not the symbols, okay? So when I say 49, think about sequentially the 49th number, not the number 49, okay? Because what symbol I use depends on what numerical base I'm talking about. All right, I hope maybe I've made this more complex than necessary. But you can see this sequence, unique sequence of 8 bits, a 0, 0, 1, 1, 2 zeros and a 1, 1, are always an A, okay? So it's a unique sequence of 8 bits, represents a specific character in, so. All right, so now the question is what's a bit? All right, and I swear I'll get to HTML and CSS eventually. But I love this stuff, so I'm forcing you through it. It's a single binary digit, okay? Now the last question is what is binary, okay? And there's a lot of information in the slide, so I'm going to read it to you and then we're going to go through it really quick, okay? But really it's a simple positional notation counting system. Binary only uses 2 symbols, a 0 and a 1, okay? Compared to what we call decimal, okay? Decimal is what we're used to, 0 through 9. Versus 16, a very other useful numbering system is it's known as hexadecimal. Okay, so there's something that irritates me. People will say 0 is the most important invention of mankind. Okay, and the reality is that my pet understands 0. It understands that its water dish is empty. Okay, so it's not 0 empty. That's the really incredible invention, and it's not the fact that we have base 10. This is an artifact just because you have 10 fingers. In fact, I don't like base 10. Base 12, with 2 more symbols, you have more factors, right? You could represent 1/6, 1/3, 1/4 in a way where you don't have to write out, a billion decimals, okay? We use base 10 because we have 10 fingers, but mentally you should realize that it's not superior to any other base that we choose. What matters is the fact that it's a positional notation system where 0 acts as a placeholder that implies the value of the digit. Right? So you could, right? So, all right. So one way that maybe you all know binary and hex. I'm gonna finish this. Okay. So the way I want you to think about this, because it's not immediately how do I translate from base 10 to binary. It's actually computationally intensive to translate from decimal to binary back and forth. Okay. You have to use a successful approximation. That can take about 8 steps. So. But really what I want you to think about is, I've got this analogy here of counters, and you have 3 vehicles that are leaving at the same time, okay? And they all have different counting systems on their odometers. Okay, and I don't know if you guys can all see that. Okay, so let's say this guy is he's in a car with a base 10 odometer. This guy's in base 16, and then this fellow's in base 2, binary, hex, and decimal. Okay, so what you can think about is the way this counter, it all starts off at 0, and then the counter starts to count, and then it gets to a 9 in base 10, and then that 9 pushes up the 1, you see a 0, right? But if I had 16 symbols on that first dial, it wouldn't have pushed up that 1 yet, okay? It would keep going, so it would show 1 through 9, and it wouldn't go 1, 0, it would show an A. And it would keep counting B, C, D, E, F. So until that first symbol gets to F, then it'll go back to 0 and push up a 1. All right, I hope that makes sense in some conceptual way. If you just think of a dial that has more symbols on it, okay? So really, the first step to understanding different counting systems is just to count, all right? And it'll make some sense. One thing I didn't say is in hexadecimal, the symbols we use are 0 through 9 and A through F, okay? So just remember that. Again, it's a standard. When you say hexadecimal, these are the only symbols you're going to use to represent a number, okay? So again, and then finally with binary, you can imagine it's all zeros. The first click counts up to 1, 1, 0, 0. The next click will then put that 1 is the last symbol, so it pushes up a 1 in the next column, right? And so, and anyway, I'm hoping that sequence, if you just think it over, I promise you, maybe it'll come out of it. It's funny, I had a conversation with one of the computer scientists here, and he was like, he said the first professor that talked about binary numbers, he said he did such a bad job that he called him up to the front of the class and said, you teach it? And it's not clear if he taught it any better. It can be a pain to teach, okay? But anyway, I'm hoping that analogy was useful, okay? So the question is why hex, all right? And so hex is to keep, really it's to make the computers, keep the computers from going crazy, okay? If I go ahead and have to do decimal all the time, it's computationally intensive for the computer to go ahead and convert decimal into binary, okay? But I, as a human, don't want to write a huge sequence of 1s and 0s, right? Suddenly I'm representing a nice number 12, I used to do it with 2 squiggles, and now I'm in binary, I gotta do 4 squiggles, right? And it explodes after the numbers get larger. So hexes are truce between human and machines, okay? It's a nice bridge that allows us to go ahead, instead of writing binary, we can easily convert 4 bits of binary into 1 hexadecimal symbol. Okay, so now humans are happy because I can remember 16 symbols. That's not so hard, okay? More than that, it might be difficult. And then the computers are happy because it's very easy for it to go ahead and translate a hexadecimal value back to the binary value, which is its native numerical system. All right? Okay, so literally, I mean, again, here's that counter we talked about, 0, 0, 0, 1, you know, the rollover pushes it. So you can kind of see a cascade here. All these values, of course, unique, and you can see a pattern there. Maybe it helps clarify the binary counting system. And again, 0 through F for hex. All right. So let's take a quick example. So this was Google's IP address, okay? But again, that IP address, we wrote it in decimal. The computer doesn't understand decimal. What the IP standard calls for is a 32-bit number, not 4 decimal numbers with dots in between. Okay, that's just makes it easier for you. All right. So the reality is, if you were to go ahead and run that counter 74 times, you'd get this binary value. 125 times, you get this binary value, and so forth. There's your 32 numbers. The spaces don't matter to the computer. It doesn't care, so it just goes ahead and smashes them all together. And that's the 32-bit address for Google's heading router. Okay? So then, if I told you to write down the 32-bit address for Google's heading router, it would be very frustrating. Nobody wants to do that. But a quick way you can do that is segment it into 4-bit chunks. Okay, now there's only 8 chunks. And then really you can either go back to your lookup table, or you'll start to get used to it. You'll know that's a 4, that's a 10, that's a 7, that's 11, and so forth. And now I have a hexadecimal number. So it's very easy once I break it up into 4-bit chunks. You can go back to that lookup table I showed you before and convert those 4-bit chunks to a hexadecimal value. Okay? All right, so that is Google's IP address represented in hexadecimal. All right. So last question. Why binary? Okay. And why digital? So when we talk about a digital circuit, we mean a circuit that that uses the binary as its reputation for its representation for values. Okay. So if I were literally to go ahead and let's see here, let me go back. If I were literally to open up a text editor on my Macintosh and just type in one letter A, I could open my Mac, assuming it's still running, find a memory chip, I could etch off like the cover of the memory chip, then nitric acid, I could remove the glass that protects the memory chip, and I could literally take a needle, a microscopic needle, and probe somewhere in the memory chip and hook that needle up to a voltage meter, and I could literally measure a 0 volt, 5 volts, 5 volts, 0 volts, 0 volts, 5 volts, 5 volts. Okay, you can literally find that somewhere in the memory. Okay, so here's the other thing: a computer doesn't think in ones and zeros. All a computer circuit thinks about is the absence or presence of voltage, and that's it. Some chips run at 5 volts, some chips run at 1.8. It doesn't matter. If it's a digital circuit, you will only find one or two values somewhere in that circuit when you probe around. It's either 0 or 1.8. Assuming you've stopped the clock and these things aren't racing around. Okay. So let's go through this quick. All right. So the last point, there's so many reasons we use digital. I'm not going to go through all of them. Okay. But really, you know that the other alternative is analog, right? So there's no reason I couldn't take a 9-volt battery and say I'm going to represent, instead of 2 values, I'm going to represent 10 values: 1 volt, 2 volt, 3 volt, etc. Okay. The problem is analog circuits tend to be bigger. Their manufacturing costs are more expensive. Now, if I do a 32-channel analog circuit as opposed to a 32-bit analog circuit, I have to worry about matching. It's just a pain to manufacture. Okay. But if I do something where I have a transistor and all that transistor has to do is detect whether a voltage is present or not, that can be the crappiest transistor. The minimal needed to manufacture will work because all it's doing is detecting if something's present or not. Okay. And the nice thing is, because it's crappy, we don't have to make it very big. We can make it smaller, and magically, when something gets smaller, it runs faster. Okay, because of the parasitic capacitance and resistance in the circuit. Anyway, I'm really off the deep end here. I guess the point I'm going to make is that the signal-to-noise ratio is the optimal when you do digital. So let's say here, this was a really noisy environment, and I'm trying to talk to somebody here. They can't hear a word. Then at the end, I can make a Morse code style communication system where all I do is just yell something, like any noise, and then stop yelling something. And we could go ahead and communicate through Morse code. Because in the end, you can optimize your signal-to-noise ratio just by having 2 values. All right, so that's why we use digital. I don't know if that was a useful class time here, but anyway, I had fun talking about it. That's a consolation. Great. So it's quiz time. Find your quiz buddy and go forth and answer.
What is that?
Is the standard language. And so
I can't remember code. What has to we all agree that the numbers and the letters and everything. I'm saying again?
Okay, what is adding mean?
It's just a way to encode so that it's kind of the human interface between the computer, because the computer just understands zeros and ones, and human needs to really understand that. So it's a
I didn't
translation
cover question one. I apologize.
language.
Robot explained it all.
Angry robot.
So it's not really standard for HTML. HTML needs to have some kind of
Presentation.
It's the numbers and then the letters afterwards, right?
Is that what he said? Was
I'm
Okay, how do we
going to go ahead and Zoom since okay.
like an A will translate to, like he was talking about,
Again,
to
ASCII is an
00011
standard for encoding 8 bits to standard alphanumeric punctuations and numbers. Okay? Standard and 8-bit are the most important words there. What are the symbols used by hexadecimal? 0 through 9, A through F. Those are the symbols. That's 16 total symbols. What is adding reading zeros to a counter column? I apologize, I did not cover that I'm going to cover it. It comes up a lot in computer science. Okay? So in this case, you can see that, let's say I had a vehicle and it only had 3 digits, all right, in its odometer. It's not a very good odometer, right? Most cars get more than 1,000 miles, and pretty soon that odometer means nothing, at least in an absolute sense. It means something relatively, right? So you always have to think when you have a number in formal computer science, how many bits it is, because that's, it might be more detail than you need. But bottom line is by going ahead and having these leading zeros here, you've indicated the level of accuracy that counter can have, right? So you have to make sure that, and so the other thing is in computer science, very often we do put these leading zeros in. And I don't want them to confuse you. When you see a 0 in front of a number, it's still that same number. Just like, like this is 12, even with all the zeros in front of it. Okay, it's just a different way. Because a very common programming error is what they call a counter rollover error. Where suddenly your counter is rolled over, you didn't take that into account, and now that counter is meaningless, and now your autonomous farm vehicle is going after rabbits or whatever it would do in that code. So, all right, so I love the angry room. Oh, I guess there's a few more questions to answer in the quiz. Why do you use hexadecimal? It's a nice compromise between man and machine. Okay, it lets us quickly transcribe binary numbers into a number with less digits. Okay. All right, HTML demo. All right. Let's see if we don't fall apart here with the demo. All right, so let's take a look. I've got a directory, actually. Oops. I'm never going to master this microphone here. Oops, sorry about that.
We'll get you one of the over-the-ear ones for next time.
Thank you. I'll manage to be so hyper-spastic and not that all my kids. Old school. All right, I'm giving myself one more shot here. I've got to scroll that screen up. You guys can't see that. I'm just going to move on and show you the code here. All right. Okay, so I have a really simple HTML file, okay? And unfortunately, I can't reach this. Maybe I have a little laser pointer on this guy here that can go ahead and, oh, the batteries aren't very good. Okay, well, anyway, you can see that at the very top, I have an HTML tag, okay? HTML is all about this concept of tags. All right, tags kind of nest other objects inside of other objects, okay? So everything, and this is really the simplest valid HTML page, is really just open the HTML tag and close it. It's just an empty document, okay? But you can see that, that we have that HTML tag way up there, and I've gone ahead and done a nice coding convention by adding an indent every time I have a tag that encapsulates other tags. It makes me, as a human, and my friends, makes it easier and more fun to read this code. The computer doesn't care if you have any tabs, any extra spaces. It rips all that out of your HTML file, and I'll show you that in a minute here. Okay? So the other thing is it's going to be very helpful when you dynamically modify your HTML through JavaScript to start thinking about the page as some non-traditional family tree. Okay? And by that I mean that children only have one parent. There's no mother and father. Okay? There's no concept of grandchildren's aunts and uncles. There's concepts of siblings, children, and descendants, though. So you've got the concept of parent, which is the immediate tag. So, for example, if I look at the head tag all the way at the top, there's nothing in it. Ah, this pointer sucks. You guys can see it. The parent of the head is HTML. HTML's tag has 2 children, head and body. HTML's tag has a ton of descendants, though. Everything in the HTML tag is descendant. So we have these words that kind of go back to you just thinking about a family tree, descendants, children, and those are used in formally they're really used by jQuery. And jQuery is my favorite extension of JavaScript. If you're going to when do you use jQuery? Anytime you use JavaScript, you're going to use jQuery would be what I would just by default say, okay? Unless you're using JavaScript in some other context. And I will say something. Next lecture I'll say. Okay, so anyway, so you can see that really the head tag is really just for external links, and I'll show you what to do with the head tag, but for now it's empty, all right? All the content and all the layout for the web page is inside the body tag, all right? So look at the first line of a body tag. We have an H1 tag, which is just a heading, okay? So I have this nice web page that goes ahead and lets you know who's born on today, okay? And so born actually on August 16th back in 1886, and then you can see that I have this div tag. And a div is a container. We use it for layout, okay? So div really doesn't do anything unless you add a background color to it or background image to it. It's really just to go ahead and contain other HTML tags, so you can go ahead and move this object around. Let's say you had a bunch of paragraphs and pictures. Instead of having to move one picture and paragraph, you can contain it all in a div, and now just move that div. And all the contents move around. So a div is just a container for floor planning your page. Okay? It's very, very common to use. All right, so the div has two children. It has an image, all right? And you can see that every time you open a tag, you have a corresponding closing tag. So these open and closings never like interlock, okay? You always go ahead and close the last unclosed tag, right? So you can see here that div is not going to close the P tag because the P tag was closed here. It doesn't close the span tag. It goes all the way to the top. There are two self-closing tags on this page, okay? So not every tag can have children, all right? It doesn't make any sense to have children inside the image, all right? You can make it a sibling to the image by putting in the same div, but image immediately has this other slash here, which implies we just immediately close that tag. So that code is equivalent to me putting another, open bracket slash img to imply it's closing, okay? So then the next line is P for paragraph, all right? So you have this concept of paragraph, and you have this other concept of span. The span is a text snippet, all right? Usually you use span inside of a P tag, okay? And that's because maybe through JavaScript or maybe through some style property, I wanted to make birthday change colors every second. So how can I refer to it? The only way I can refer to it is I wrap it inside a span tag, and now through jQuery JavaScript, I can go and look through the DOM, which is this family tree we'll talk about later, okay? But we can look through, let's say, the HTML elements and find that span to dynamically change its properties. All right, so anyway, so span is usually used for a text snippet. A paragraph goes ahead and is for a block of text, okay? You can kind of get it based on its name. All right, so there's another, I guess there's a lot I can go on this slide. I'll continue. I'm hoping this helps. If you look at the way I wrote its, I didn't put its. First of all, I know how to spell its, right? It has an apostrophe, okay? And you can see though there's certain characters that throw off the web browser, because you have to understand the web browser reads in this HTML and then goes and creates what's called a document object model, its representation of the HTML page. So when you go and change this stuff dynamically with jQuery and JavaScript, you're not changing the HTML file. You don't have the rights to change it. It came from Google or someplace else in some cases, okay? So all you're doing is changing it's like you're working on like an MS Word. When you're working on the actual document, you're not changing the underlying file. You're just working on the live document. Okay, so I think you should keep that thought separate. I'm not sure it was helpful to introduce that concept right now. Okay, but so anyway, so the web browser's reader goes, and there's certain characters that will throw off the web browser if it's in your text. One character for certain that will throw the web browser off is a less than symbol. If you wanted to say Carrie is less than 200 years old, and you put a less than symbol, the browser starts to read and says, oh, less than. Less than means he's starting a new tag, and then this whole page falls apart. Okay, so you have to have this concept of escaping the special characters. All right, and some web browsers have no problem with an apostrophe, others do. So apostrophe is something I personally like to escape. Okay, and one way you can escape an apostrophe is by putting an and a hash mark, okay? Look, the thing is, you don't have to write this down. What you have to remember is this concept of escaping characters. If you remember that name, you can look up how, okay? So in this case, this 39 refers to the 39th ASCII character. So you can always put this ampersand and a number symbol a number symbol followed by a number to say, hey, represent this with the actual ASCII value, okay? There's other ways to do escape characters. Apostrophe can also be done with an ampersand, apos, semicolon. Okay, so sometimes you see these weird little tags. They're just to escape the special characters so that the web browser doesn't get confused. You can just go, okay, no, he means an apostrophe. He doesn't mean he's starting some type of string or variable or whatever. All right, I hope that's helpful. All right, so there's an HR tag. HR means horizontal rule. Rule is a word from the typesetting industry that, if you have a ruler, it's not called a measure. It's called a ruler because rulers rule things. You go ahead and you draw straight lines. A straight line is a rule, okay? So that means draw a straight line. All right, we'll see that in a second. And then, I'm almost through it. I'll go through the rest of it. I forgot to escape the apostrophe. You'll see the Firefox doesn't die. But you can see that I have this, I have extra spaces here. I went ahead and put in a carriage return or an enter. The line is a mess. But because the HTML reader, the web browser, ignores extra white space, ignores all these extra tabs or whatever, it's going to go ahead and it treats all these sequences as one single space. Okay? So you can see that it's a mess here, but just always remember that the browser, you can't hit a bunch of spaces and expect to get a tab. All right? You will get one space. There's special escape characters you can use to go ahead and get tabs, or if you wanted to go ahead and do an actual line break, you'd have to put in the BR tag. All right, so I don't know, maybe, should I continue on this page, or is this please.
I was hoping to ask one question. It may be too much detail to go into. The span is always confusing, but if you put a span on that worn on and did all those spaces, wouldn't it keep all those spaces in there? Is it kind of a literal kind of thing?
No, it wouldn't.
It doesn't.
It wouldn't. There's nothing you can do to get extra spaces other than put in the space escape character, which is ampersand NBSP, non-breaking
Does it do
space.
some strange rules about inline and block? Change it.
You know what? I don't know. I can try. I'll try at the end of the class. Okay? Because I'm actually not sure.
Okay, I don't
I've never tried it. No, that's interesting. It'd be nice to know if span goes ahead. Actually, I'll tell you the tag that I know for certain will go ahead and keep, for example, if you have a form on your website and the user can go ahead and type in a paragraph, if you want to keep all of his extra spaces and all that, there's the tag called PRE, pre. Pre absolutely preserves all the spaces and tabs. Okay, and it's a very useful, not very well known tag. Okay.
You mentioned that how that's all laid out, however you want it spaced out. Does it make a difference if it's actually put together all together as far as the code itself? So
No, it doesn't make any difference. I can write this on one long line.
So I'll right click on view source on some websites, and you'll see some of them that are just long, and I've seen some that are really pushed together.
Right, there's a whole concept called minification. Okay, so I'll mention this real quick. So what a lot of times you'll see this code, and the code looks unreadable. Okay, and sometimes they do it for obfuscation, if I'm pronouncing the word right, because the guy wants to protect his intellectual property. He's not going to make it easy for you to read. So therefore, he crashes everything together. He removes meaningful labels from variables and so that's called obfuscation. But the other thing is that bandwidth matters, and it's valuable, and therefore if I can reduce characters that aren't going to get used anyway by the browser, why not take them out, right? So in this case, yeah, you could start taking out characters, and it might be a millisecond different though in your page load time. So I don't know if it's valuable, but people do minification, especially on JavaScript. You'll see with the jQuery plugin, there's two versions: the developer version and the .min version. They're the exact same code. But the developer version kept all the meaningful labels in there, all the comments, and that's 2 megabytes. But if you look at the minified version, it's about 161 kilobytes. It's less than a tenth of it. Because by the time you pull out all the comments and all the meaningful labels, you get a much smaller file. Because it's a much smaller file, your page load times will improve. All right. Okay, I'm actually just going to go ahead and show you this page. You get the idea. You can draw a table. You can look it up. How do I draw a table? How do I, so. But again, really what I wanted to take away here is to be some of the escape characters and this concept of children. All right. So again, if you look at the table, how many children does the table have? Well, children is the first descendant. So it has 1 row, 2 rows, 3 rows. It has 3 children. How many descendants does it have? Well, it has the rows and then it has the cells, so it's more like 8 or 9 or something. Okay. Anyway, I'm going to actually just show you this page real quick. and then maybe change one styling property. So remember I said I have map running on this computer. I can just type in localhost now, or I can type in HTTP : localhost, and it goes to my own computer. Okay, I'm going to close this real quick. So let's go map. Let's go ahead and look at the birthday. So you can see in this. All right, hold it. You can see that in this directory. Okay, for the example, we have the example HTML file which I just showed you. That example file referenced one external file, and that was the PNG file. Okay, and there it is. So this directory only has 2 files in it. Okay, we go ahead and look at it. Oh, I changed the background color behind the birthday cake. All right, but you can see it. Tables generated, and one thing you can see here is that the tags just get rendered on the screen straight down in a column. Okay, so that's what's useful for the span tag. For example, if I put birthday in another paragraph tag, paragraph implies it's a new block, and that means it would start over again on this side here and just render it, top to bottom. Where span is kind of still something that doesn't go ahead and tells it to start a new line and start a new object. Okay, so if you remember, we had the H1 tag. The image then didn't go over here. It went right below it, and the paragraph goes right below it, and the horizontal rule goes right below it. So you can see that it just generates the page from top to bottom. All right. There's a really helpful styling tag called float. You can say float left, and that helps you go ahead and say don't put the new object beneath the current object. Put it to the side of the current object. Okay, because that's something that's really frustrating, being able to control your page layout. But I'll show you how to do that as well. So let's see how we're doing on time here. All right. So let me go back to the presentation. I didn't forget anything. What I didn't show you is I can put a style property on the back of one of the divs that's called background color. Okay, and I put a background color behind the image. All right. Let me show that really quick. Okay. So I can't hold it, unfortunately. So if I went ahead and just went, oh, you can see I do have the stop tag in there. I take it back. Right there, I said on this div, I want a green background. Okay, and I'm going to show you why that's green in a moment here. All right. But the other thing I need to point out is that you can see that the green actually envelops the entire cake. All right, and that's because the cake is a .png file. A .png file lets you have transparent backgrounds. Okay, a .png file actually is a 32-bit color format, and one of the bytes allow you to have alpha channels so that you have some transparency. So you know what it's like. You get a picture, and suddenly the picture has a white box. But you have a pretty background, but then you get this white bounding box around the whole picture. If you use a file format like JPEG, you're stuck with that white box. Okay, you have to save it in PNG. And GIF does it as well. Okay, and they have the alpha channel support, so that you can go ahead and show the background, so that there isn't this white bounding box. Good. All right. All right. So let's just spend a minute on color here. And again, maybe this is something all you guys know, all right? So we say 24 bits, right? So 24 bits is six 4-bit values, right? If you remember, 4 bits translates to 1 hexadecimal number, and therefore 24 bits can be represented in 6 hexadecimal numbers, okay? So when we say RGB, there's a really interesting limitation of the human eye that makes display manufacturers very happy. Okay, and that is that you can represent all the monochromatic colors of the rainbow with just 3 colors. Okay, so it's like if I had a piano, all right, and I could play the individual notes. You can all hear these individual notes. But if I then played a chord like a C and an E note, you would hear a D note. You can't hear a chord. Okay, so maybe that wasn't a good example, but look. So you have these RGB values. Okay, the first value here is for red, green, and blue. If it's all 0, you will see nothing, right? FF. FF is the largest 2-digit hexadecimal value there is. It's like 99 is the largest hexadecimal number there is. Okay? It's just the last symbol in the sequence, FF. FF means maximum red, no green, no blue. All right, on and on, green, blue. So we have this nice thing that happens with our eyeballs. You go ahead and shine red, green, and blue light directly in your eyeball. You don't see red, green, and blue. You now see white. All right, so again, you could take a magnifying glass. Most people know this. You take a magnifying glass to your screen. You can see it's all made up of red, green, and blue pixels. All right, there is no white pixel. There is no yellow pixel. In fact, yellow is very interesting, right? Yellow is a combination of red and green. Stick a red light and green light shine in your eyes, you see yellow. You see monochromatic, you can't distinguish from monochromatic yellow. All right? So you can see that you kind of get this idea. You think in your brain, like, okay, what if I wanted orange? Well, orange was red mixed with yellow, but yellow is red mixed with green. So how did I make the red maximum and I make the green at the halfway point? So remember, if I had 99 as a maximum in decimal, the halfway point is 50, right? In hexadecimal, FF is the largest value. The halfway point, if you look at the sequence of numbers, 8, right? So kind of 80 is in the middle of a 2-digit hexadecimal value. All right, was this helpful?
Yeah.
Good. Two things that I like when I do development work. I like using Firefox. I find that Firefox is, I like to do my initial development in Firefox first, and then occasionally I'll test in the other browsers. All right, so anyway, that's my personal preference. People debate it. I'm just telling you that's what I like, okay? And what I really love is Firebug. Firebug allows you to do introspection on the HTML elements, and I'm going to show you, it shows you, you'll see with CSS. Actually, I'll do a demo of CSS in a minute here, okay? So if you Google license, driver's license, the #1 license you'll get is Tupac Shakur, okay? But I do like his music, so he's up there, okay? And the reason the license is up there is because people get a little confused with this ID and class attribute that we can put on HTML elements, okay? But if you think about it in context of the natural English way we use ID and class, this becomes a lot clearer, okay? So, so don't forget, every single HTML element I can put on these 3 attributes. I can put in an ID, I can put in class, and I can put in style. They're the most important attributes for an HTML element, okay? ID, class, and style. All right. So if you think about a California driver's license, if you think about the ID number, there are restrictions on this concept of ID. The first restriction is IDs must be unique. This fellow and only Tupac has this ID number, okay? Nobody else has. The other thing is that he only has 1. You can't have 2 IDs. And a third thing is completely arbitrary, all right? Maybe the driver, the DMV wanted to put 2 A's in front or whatever. You come up with any naming scheme you want. The browser doesn't care. It just cares that if you're calling this element by this ID, because I can't call it by the type, there's a number of divs in my document. So if I say, hey, get this div because I want to change the color, it's like, which div? It's going to assume you mean all of them, right? So instead, I can say, hey, get this element by ID. Here's the ID. It says, great, I know which one you're talking about, all right? So class, this is the only doctoring I did to his license. I gave him a motorcycle endorsement, okay? But you can see class is a little different. Class doesn't need to be unique, okay? And you don't have to only have 1 class. You can have multiple classes. So you can issue a parking ticket for this ID and say, but also give him a registration notice because he has a motorcycle endorsement. Tell him it's $50 extra for the registration. Okay, so this allows you to go ahead with class, allows you programmatically to go ahead and select a group of elements that for some reason you wanted to have grouped for whatever reason. You can programmatically change their style and select them. And then everything else is shoved into style. Okay, so when we talk about CSS, this would be an inline CSS example. Okay, the CSS values live inside the style attribute if it's inline. Okay, and I'll show you what that means in a moment here. All right, let's see. So the thing you have to remember with CSS, you always have this property, name, and value pair. All right, it's a long string that's semicolon delimited with the property name and its value. The most common mistake people make is they put an equal. In this, they put colon is the way you imply equal inside CSS. Okay. The other mistake they'll make is they'll forget the semicolon. In which case, it'll say the weight's 168, and then can't figure out anything else. Okay, and we'll see there's these style properties on HTML element, like background color we saw with height. You get it. So anyway, it's just this long string, semicolon delimited property value pairs. All right. Let me see where I am in this presentation. I would like to take like a 2-minute break here. I'm sure maybe some of you guys do as well. All right, I think we're okay. So let's get through a little more here. I honestly can't remember what I was trying to communicate with this slide, so we'll just do some quick. But you can see again, in this HTML snippet, I have 3 divs. And you can see the 3 divs have different IDs. And is this ID okay? Well, I look through the rest of the document. If nobody else has it, we're good. If somebody else has it, you made a mistake. All right. Class again, it's okay. These both have class in small boxes, okay? And sometimes this is why I use the driver's license example. People get really confused and suddenly think, oh, small boxes must be some meaningful tag to the web browser. Small boxes doesn't mean anything. I made that up. I could have called this Bob, Frank, and Harry. It would work just fine. So you have to differentiate the difference between reserved keywords and values. Your values are what you want to make them. Reserved keywords are golden. You can't change it. The browser needs something special to the browser. And then you can see this long list of style property value pairs, semicolon separated, right? So you kind of get how this is going to be rendered based on that. Okay.